All right. So what we're going to be doing today is called transformations of parabolas. Did you guys do this in grade 10? Grade 10? Yeah. Okay. So we're going to review it again by doing Desmos. So quadratic equations can be written in vertex form. So we have f of x equal to a times x minus h squared plus k, where a, h, and k of the vertex form an important part in transforming the function f of x squared. So when it comes to this f of a or f of x equal to a times x minus h squared plus k, does anyone remember what h and k represent on the graph? What does h and k represent? HK. It represents x and y, but it represents a specific point on the graph. Olivia? No. Nope. It represents something like one of the most important parts of a parabola, where it changes direction. What is that called? I heard someone say it. Vertex. So H and K is the vertex. I think it says in there. I don't know. I don't remember much from this. No, I didn't say anything about vertex. So H and K, they're the coordinates of your vertex. So K is the easy one to remember. This is easy. H is the one that changes because it's in a bracket. And we'll talk about that after. So everything to do with the Y, the A, and the K are easy because they appear as what they seem. The H is always opposite of what it seems in the bracket. And we'll learn more about that once we get to the transformations. So we're going to start by investigating K, which is the guy at the end. So K is the guy at the end of f of x is equal to a times x minus h squared plus k. We're going to be talking about this guy over here. So now we want to figure out what x squared is. So I'm going to open a new tab on open Desmos. So graph. Okay. So I'm going to get y is equal to x squared. Okay. Y is equal to x squared. My vertex is going to be 0, 0. Nothing's going to happen. Now, the first equation that we're going to look at is we want to look at x squared plus 8. So when I type in the other equation, y equals x squared plus 8, what do you guys think is going to happen to that graph? Is it going to start at the same place or is it going to move somewhere? Which way? Up, down, left, right, diagonal? It actually moves up. Okay? Yeah, I heard someone say up. Now, if let's say we take x squared minus 4, is that going to move up or down? Minus 4. So as you can see here, when my k is positive, it means my graph moves up a certain amount of spaces. If my k is negative, my graph moves down a certain amount of spaces. So how are the graphs similar? How are these graphs similar to each other? Sarah? Yep. So what is that called on the y-axis? Starts with a V. The vertex is on the y-axis for all of them, right? So what's similar is that the vertex is on the y-axis. And what is different about these three graphs? What's the difference? So Sarah said the x's are the same. Olivia? Yeah, the y's are different. Of the vertex are different. So K has to do, I'm going to write it here, tells us how the graph moves up and down. So if there is a plus in front of the k value, it moves up. If there is a negative in front of the k value, it moves down. So I'm going to write it over here, plus. Then this negative means moves down. Any questions so far? Pretty basic from last year. Okay. So now we're going to focus on the a part of the vertex form. So that's the number that comes before the bracket. So we're going to graph again, x squared. So we're going to take out these graphs over here. So x squared is going to be our parent graph. So that's our graph of reference. We always look at x squared before comparing it to anything else. So what we're going to do first is we're going to graph y is equal to 3x squared. If I put that number in front of the x squared, what do you guys think is going to happen to that graph? I'm going to put before I press squared. What do you guys think is going to happen? Is it going to do something to it? Sarah? Wider or skinnier? Let's see. So Sarah says wider. Anyone think it's going to get skinnier? Olivia? Skinnier. So it gets skinnier. So it stretches out like an elastic band. So you have an elastic band that's normally, once you stretch it out or add a big number in front of the x squared, it makes it skinnier. So if I were to add a fraction to it, what would my graph look like? Wider. How do I do a over thing? One over 2 x squared. So it becomes fatter, okay? So the rule here is when you have a fraction that is between 0 and 1, so like 1 over 2, 1 over 3, 1 over 4, your graph is going to get wider. However, if you have a value in front of the x squared that is a big number over 1, like 2, 3, 4, 5, 6, 7, your graph is going to get skinnier going up. It's going to get thinner. Now, the other thing about the a value is there can be an a value that is negative. When we have a negative in front of my, let's say, 3x squared, what do you guys think the graph is going to do? If I add a negative in front of the 3. Jade, you said it? It's going to go down. So when I add a negative in my a value, that tells me my graph is going to open down. So how were the graphs similar in this case? What do you notice about the vertex of all the graphs? They're all the same. What are the two differences about these graphs? Two differences. What are some differences you notice? Yep. So some are wider and skinnier than others. And what is the other thing, Jade? You mentioned it about going. Yep. It can go up or down. Okay, so I'm going to write what A does over here. So the A value, it tells me. Oh, did someone ask a question? Okay. So it tells me if my graph is stretched or compressed. And it also tells me which way my graph opens. So how do I know if my graph is stretched? What does my A value have to be? Olivia? Stretch, stretch, stretch. Yep. So for it to be stretched, A has to be bigger than 1. Now, Olivia, just repeat what you said about compressed. Less than 1 or bigger than? Yeah. So A has to be bigger than 0, but it also has to be less than 1. Because if I have a fraction of 3 over 2, that is 1.5, so that would be considered a stretch. If it's 2 over 3, because it's 0.66, that is considered to be a compressed graph. Questions or confusion so far? Or is this pretty straightforward? Yep. What's up, Rita? Yep. So like I said, like 1.5 wouldn't count because 1.5 is bigger than 1. Compressed. As long as the decimal is between 0 and 1. Like I said, 1.5 doesn't count because it's bigger than 1. And like we said, if A is negative, that means my graph opens downward and goes down in the downward direction. Just going to move it up a bit. And now the last one is going to be H. That one is the trickier one because, like I said, it's opposite of what it actually appears because you're actually solving for uh, solving it as an equation where you have to isolate for x. Does that help us find the x value of our vertex? So again, if you're copying, I'll just be brief. I'm just gonna put these away, and you guys can continue copying that. All right. So we have to worry about h, which is the part in the middle of our vertex form equation. So what do you guys think is going to happen when I have a plus or minus inside the bracket, Sarah? Okay. So if I have x minus 2 squared, which way is that going to move, left or right? Think about what I said first. It's opposite of what it actually seems. I said h is always opposite of what it seems. So if I say x minus 2 squared, which way is it going to go? Right. As you can see, it moves to the right. And if I have a plus, which way is it going to go? To the left. And I'll show you guys. Square. Okay, so what is so x usually has to do with my x intercept, right? So if I want to solve the x intercept or the x value of my vertex in any parabola, I have to set my value in the bracket equal to 0. So I'm going to have certain equations such as, in this case over here, I will have to set x plus 2 equal to 0 because that is where my graph changes direction. So if I were to move the 2 over, what happens to the 2? So this means that my graph moves 2 spaces to the left. So we're solving the bracket by setting the bracket equal to 0, so I can figure out what my x value of the vertex is going to be and which way my graph moves. So what do you notice about the y value of the vertex in these three graphs? What do you notice about the y value of the vertex? No, not the x's are different. What about the y values or the k values? So if you notice in these 6 equations, do we have a k? Do I have like plus or minus a number after? No. So what would my k value be? 0, which means the y value of my vertex is going to be 0. Oh, similar. Whoops. Yeah, y value is 0. What is different about the graphs? What is different about these 3 graphs? Olivia? Yep. They have a different x value for their vertex. And then again, I'm going to write the definition of what h does. So I'm going to write h down here. So the first part is always opposite of what it seems. Tells us which way the graph moves left or right. And it helps us with the vertex. Okay. So if I were to give you guys an example, and I were to tell you guys to find the vertex, So what would my vertex be for f of x equal to x plus 2 squared minus 5? Remember at the top I said the vertex is given by h and k. So what would my vertex be in this case over here? Let's see if anyone can get it. What would my vertex be for that example I just gave? I'll zoom in a bit. Remember, h is always opposite of what it seems, and k is what it appears to be. Yep, that would be my vertex. -2, -5. So if I were to ask you guys, so tomorrow we're going to talk about how to actually write this in sentences. The transformations with it for this would be, my graph is translated 2 units to the left, and it's vertically translated 5 units down. But we'll worry about that tomorrow. So any questions about this before you guys do your textbook practice work thing? Rita?
H is always what's in the bracket, and K is always the number.
Yep. So this guy over here is H. And like I said, H is always opposite of what it seems. And this guy over here is K.
Would there ever be another number?
No, we're not going to do horizontal compressions or stretches, so don't worry about that. The only difference from this one and advanced and the functions is that they teach you guys stuff that has a number in front of the x, but we don't do that. This one. So apart from the x being the weird one, everything else is pretty straightforward for this lesson.